Dear friends, welcome back to the channel. Today we are diving into Natas, a war game from OverTheWire designed to sharpen and improve your web security skills. Before we get started, make sure to subscribe to my channel and give this video a thumbs up. It really helps the channel grow. Now, let's jump in and start hacking our way through Natas. The level I'm going to do will be level 7. In this video, we will deal with local file inclusion vulnerability, which is one of the most important vulnerabilities for web applications. Of course, as the previous levels, I will also use Python to do this level as well. So now we can copy this address or URL as starting point. We can copy and paste into address bar of the browser. Press enter. And we are required to provide username Natas7 and its corresponding password. We can copy it from notebook and paste in here. Sign in. Don't save. There is nothing on the page except 2 hyperlinks. We can open them in new tabs, and also this one. And as before, we need to check its source code. Here, give us the hint. The password for the next level is stored in this path or in this file. We can copy, and maybe we can open new notebook. Oh, not this one. We can copy it from the source code and paste in here. Okay. And so how about the home page? This is about the page. We can check its source code as well. Nothing here. And this is the front page. Nothing here as well. You know, we cannot find anything from source code except that hint. However, if you look at the URL here and also the about, you know, this seems very suspicious. As you can see here, there is parameter name, page, and home. And we can give different value for this parameter. Then we can get a different page. So maybe this is some kind of file inclusion vulnerability involved. As you know, when we write web applications, we often need to access additional server-side files located in the application directory or, you know, its subdirectories, right? For example, developers may want to include configuration files and application modules to access and display files uploaded by users, such as images or text files. So to access such files, developers commonly pass file names via user input. And this is this one. So this should be the, you know, the input parameters, user input parameters. For example, if the application is to display images uploaded by users, and the the developer will allow arbitrary names for these images. Okay, so I think this is what file inclusion vulnerability lies. And you know, such a vulnerability allows malicious user include an arbitrary file name or pass in user input. Okay, for here user input is this one. We can change it to anything else. Okay, so we can check whether we have access to. Normally, we will use one file to test file inclusion vulnerability. Because this file is always in the Linux system, and of course Windows, maybe we need to use different files to test. But now we are dealing with Linux machine, so normally we will check to see whether this we can use this file to test whether application is vulnerable to file inclusion vulnerability. Okay, if we can, and then maybe we can try to access other files, because this means the application is vulnerable. Okay, so let me copy and paste in here. As you can see, we successfully retrieved the content of this file. Again, this confirms our early guess. The application indeed is vulnerable to file inclusion vulnerability. Okay, always use this this file to test local file inclusion vulnerability. However, sometimes we need to add more. We need to change its payload to test. As you know, in the Linux, double dots means upper directory, so we can add enough // to make sure we can arrive at the root of the directory, and then we can put and we can start from the root. In case, for example, here, if we can traverse to the root directory and then access this file. Sometimes this are very important. We can copy. Let's test. But of course, now we have already used the first approach to retrieve the password file. Okay, let's press enter. As you can see, this time we still get the same result. Okay, so now it's time to check whether we can retrieve this file. We can copy and put over here, press enter. Great. As you can see, we successfully retrieved the content of the password file for the next level. Okay, next I'm going to show you how to use Python to do this level. Okay, let me open up editor of PyCharm and right click the folder what we are working on and go to new Python file. And so we can use any name like Natas 7. We do not need to put the extension of py, okay? Because editor of PyCharm will automatically add extension for us, okay? And as the previous level, we need to import something. Import request module. This module again is the third-party module. In order to use this module, you need to use pip to install it. Okay, and next I'd like to import one class of this library which can help us to handle HTTP basic authentication. So from request module authentication and HTTP basic authentication. And I think that's all we need to import into this file or into this program. And next, I'd like to define or set the variable of the basic. This will initialize the instance for the HTTP basic authentication class. HTTP basic authentication. And we need to, give two arguments. The first one is username. This case is Natas 7, and then followed by the password for this user. We can copy from this notebook and paste in here. So what can we do next? Next, we need to define the function which can, to check the local file inclusion vulnerability. So how to do? Let me, or maybe to simplify this code, I just, okay, maybe next we can organize the code to make it prettier. It depends. Okay, so first, I'd like to send a request to the web application to see, excuse me, we can send a request to the application to see whether we can retrieve password file. If we can, it will mean that the application is vulnerable to file inclusion vulnerability. Okay, requests get, and we can define the URL. So we can copy it from here, and this should be base URL. We can put below the basic variable. So base URL, and paste it over here. So next we can, concatenate the base URL with strings. The string should be path of password file. Okay, let me show you what I mean in action. So base URL, we can use operator plus and password file. Okay, and then we need to pass the authentication argument basic. So if response status code is 200, then also we need to check whether, always password file will contain the root, right? So if we can have another if statement. If root, as you know, root always, in most cases, root user should be contained in this file, okay? In this file. And then we can use the in operator and to see whether root string is in the response. So response text. Then we can print something like, the application is vulnerable to local file inclusion. Okay. Next, otherwise we can print the application. The application is not vulnerable to local file inclusion. Okay, and if the root is in the response, then we can try to retrieve the password for the next level. So how to do? We can send another requests to the web application. So response requests get, and we can concatenate base URL with new file, and we can copy this path from here because this file contains the password for the next level. We can put over here, and also we need to pass the argument of authentication basic. Okay, and then we can print out its response. So we can use response text. Okay, so now I think, or maybe if the status code is not, otherwise we can print failed to check file inclusion vulnerability. Okay, so now we can save our code, and let's bring up the terminal window and test it to see whether this program can run smoothly. Python 3 Natas 7. Press enter. Yeah, indeed, the application is vulnerable to local file inclusion. And also we can get the password for the next level. All right, so I think that's pretty much it. I'd like to see you in the next one. Bye. Have a nice